Hey, what's up? We're going to look at the discovery of the nucleus, which is one of my favourite GCSE topics because it's a good bit of history of science and it's also a good demonstration of how science works. So in 1904, Thomson developed his plum pudding model. He did this through experimenting with cathode rays and discovering electrons, the first subatomic particles to be discovered. So the plum pudding model is basically negative electrons in a cloud of positive charge. I like to think of it as being a little bit like a chocolate chip muffin, where the chocolate chips are the electrons and the cake part is the cloud of positive charge. In 1911, some of Thomson's students, Rutherford, with the support of Geiger and Marsden, did an experiment called the alpha particle scattering experiment. And from this, Rutherford developed the nuclear model. Let's have a look at the differences between the plum pudding model and the nuclear model. First of all, there is a nucleus that is positive. There's a positive nucleus. So instead of a cloud of positive charge, we've now got a condensed central particle called the nucleus, which is positive. There is still electrons, but these electrons are now in a load of free space surrounding that positive nucleus. There is no free space in the plum pudding model. So how did Rutherford get from the plum pudding model to develop his nuclear model? He did an experiment. And as I mentioned, it was called the alpha particle scattering experiment. So he took Thomson's model and he said, I'm going to test this model and I'm going to test it to its limit. So he got some thin gold foil, which of course is made of atoms, just like everything else is. And then he got some really high energy alpha particles and he fired a beam of these alpha particles at this thin gold foil. He said this was like firing bullets at paper. You'd expect 100% of them to go straight through. In a little bit more detail, alpha particles are made of 2 protons, which are positive, and 2 neutrons, which are neutral. So these have a +2 charge. So when he fired these alpha particles, he expected 100% of these really high energy alpha particles to go straight through. And that's because in the plum pudding model, there was only a cloud of positive charges, nothing dense to repel these positive alpha particles. But when he did this experiment with Geiger and Marsden, Rutherford had quite a surprise. Instead of 100% passing straight through, only 99.999% of the alpha particles went straight through. This was a great surprise. Some alpha particles got deflected by large angles, and really crucially, 1 in 8,000 got repelled straight back. This was a massive surprise because he said it's like firing bullets at a sheet of paper. You would expect every single one to go through. This meant that J.J. Thomson's plum pudding model was wrong, and Rutherford, Geiger and Marsden had to develop a new theory. And the way they explained this was the development of the idea of the nucleus. Rutherford said there must be something positive in the center of the atoms. He knew there must be something positive because we've seen that the alpha particles were positive and they were being repelled by something positive, and like charges repel. He knew that the nucleus must be small because only 1 in 8,000 came back. The chance of the alpha particles hitting this positive nucleus was very small. And his final conclusion was quite groundbreaking. 99.999% of the alpha particles still went straight through. This meant that if the nucleus is small, atoms must be 99.999% free space. With this evidence and from these conclusions, Rutherford developed the nuclear model, which you can see here. So he said there was a small, dense, positive nucleus, and there's 99.999% free space. In summary, in 1904, J.J. Thomson developed the plum pudding model. In 1911, this was replaced by Rutherford as a result of the alpha particle scattering experiment. He fired alpha particles at thin gold foil and expected 100% to go straight through, according to Thomson's model. But in reality, this did not happen. 99.999% went straight through, but 1 in 8,000 came back. He used this evidence to make some new conclusions and to come up with his new model. The fact that only 1 in 8,000 came back proved the nucleus must be small. The fact that the alpha particles repelled proved that the nucleus must be positive because positive alpha particles are repelled by the positive nucleus. And the final fact, the fact that 99.9999% went straight through proved that atoms are 99.999% free space. And because everything in the universe is made of atoms, that means everything is mainly free space. It was a really groundbreaking discovery. This is how science works. Scientists do experiments, and if new evidence contradicts previous models and theories, those theories have to be developed or changed. That's it. Thanks for listening. See you all soon.